summer, but do you know what's even hotter? The complete one-year program by sisyaclass for mathematics from grades 3 to 10. 100% only IIT and IIT teachers. This course completes Vedic mathematics and competitive exams like Olympiads and Math Kangaroo. The classes are starting from 5th of May 2025 and all of this for 9,999. Is the price a bit high? Don't worry parents, the mega offer from sisyaclass this summer season is live. And in this mega offer, you can get this complete one-year mathematics program only for 999, which is even lesser than 2 rupees per class. Parents, what do you get these days for 2 rupees? Not even a good cup of tea. But here at sisyaclass, you are getting quality classes from IIT and IT teachers at even lesser than 2 rupees per class. Parents, hurry up, quickly click on the link given in the description below or scan this QR code to complete the payment and book your seat.
Alright dear students, welcome back to yet another video from sisyaclass, this ultimate bridge series which we have started to help students that are moving from grade 9 to grade 10. Now if you don't know, we have already started this series a long time back, and this series is available in 3 different languages, that is in English that you're watching right now. If you want to watch in Hindi, you can join Shike Sir class, and if you want to watch in Telugu, then you can join Kaushik Sir class. Okay, we have already covered chapters like real numbers, grade 10 chapter 1 real numbers. I have shown you how it is almost an extension of grade 9 chapter 1. What was that? Number system. Right. We have also studied grade 10 chapter 2. What was that? Polynomials, which is an extension, which is a pure extension, I must say, of a grade 9 chapter 2 polynomials. Right. Now we have moved to grade 10 chapter 3 as well. What was that? Pair of linear equations. And that is almost similar to grade 9 chapter 4. What was that? Come on, tell me. That was linear equation in 2 variables. I hope it is clear, right? In this video, I will be dealing with tackling triangles, all about similarity of triangles. Now, as you must say, in grade 9, you have studied congruency of triangles. In this video, we are going to study similarity of triangles. Now, what is the difference between congruency and what is the difference in similarity? All of this we are going to cover. But without further delay, let's start. So, dear students, as you know, if you don't know, then you should know. My name is Rishab. I'm math master teacher here at sisyaclass. I have completed my education from IIT Jodhpur. I've been teaching for more than 6 years now. And in my journey, I mentored more than 50,000 plus students. All right. So I'll just project before this, dear students, one very important, as you know, we have started this maths 1-year program for students that are in grade 3 to 10. Now, if you want to enroll this program, the price that we are currently giving is rupees 999 only, rupees 1000, that is 1000 less than 1, and this is for entire 1 year, not for 1 month, nothing. This is for entire 1 year, and IIT and NIT teachers are going to take care for you. You can scan here and quickly start your journey with sisyaclass. This is going to be a very, what do you say, the best opportunity of your life. All right, so let's start. In grade 9, what we have studied congruence of triangles. We have studied various criteria for congruency. What was that? Come on, tell me in the comment box. SAS, SSS. Yes, everyone knows this. All right, properties of triangle we have studied. Then we have studied that is SSS and RHS and some important theorems on triangles. In grade 10, first of all, this is an extension of grade 9, but in a different manner. But again, grade 9 concepts have to be very solid, in which we are going to discuss what are similar figures, first thing. What is similarity of triangles and what are the different criterions for similarity of triangles? Now, one thing I want to make very clear before starting this session, that in this session, we are not going to discuss any proof in detail. The reason is, since this is just a bridge series, if you want this, then you can let me know in the comment box below. Or for the best part, you can enroll in our LTC program, which again, I'm telling you is only for rupees 999. All right, so let's start without wasting any time. So in today's class, first I'll start with similar figures, then I'll discuss similarity of triangles and some criterions on similarity of triangles. Alright, so what are similar figures? First thing first, have you heard about the word prototype? Have you heard? Alright, okay, leave it. Have you ever gone to an airport or, building where you see a miniature version of the building, right? So what actually mathematicians and what architects do is, like, suppose they want to plan a very huge building. All right. Now, since this is a planning material, right? So of course they will not, do the entire building design there itself. What they do, they actually make a miniature version of that, right? And it has exact same ratios. So that is what is. Just read the definition. Two similar figures have same shape. That is, they should have same shape, but not necessarily the same size. Now you must be wondering, sir, what do you mean by shape and size? See, these two rectangles you can see, right? Both are rectangles, correct? That means both have same shape. But do they have same size? No. Here length is L1, here length is L2. Here breadth is, let's say, B1, here breadth is B2. Of course, L1 is not equals to L2, but and B1 is not equals to B2. But they are having same shape, right? That's what we call as similar figures. I hope it makes sense. Great. Now, one thing, if you remember what we studied in grade 9, congruency of triangles, what do we call congruency? Congruency means if we have two figures and they completely overlap each other, that are congruent congruent figures. So suppose if we have two triangles, let's say this triangle, and it is completely overlapping this triangle. Just assume both are congruent. Now, two congruent figures are always similar, but similar figures need not be congruent. For example, consider this case. If I place this rectangle over here, will it completely overlap? No, right? But if I take two congruent rectangles, for example, and if I overlap them, first of all, they are congruent and they are similar as well. So you will remember this right now. This is very important point. Great. All right, let's move. Now, conditions of similarity. First of all, we are going to discuss of polygons. In this chapter, we are just going to deal with triangles. So, two triangles or polygons of the same sides are similar if the corresponding angles are equal. Don't get confused. Same sides, it doesn't mean equal sides. Same sides means if two polygons we are considering three, that means triangle. Or if you are considering polygons, let's say four, then it should be a quadrilateral. So don't get confused. Same sides. I don't mean to say that they are equal. So they are similar if their corresponding angles are equal. Now, what do I mean by corresponding angles? Corresponding, as you know, we have studied in grade 7 also. That means this angle is equals to this angle. This angle should be equals to this angle, and this third angle should be equal to the third angle. Right. This is first, the corresponding angles are equal, and the corresponding sides are in the same ratio. So if suppose if this is A, this is B, this is C, okay, this is C, and this is, let's say, X, Y, and Z, then what is the condition? A over X should be equals to B over Y, should be equals to C over Z. Now, this is known as scale factor, and this is very important, dear students. For MCQ type of questions, this can be asked. What is scale factor? The ratio of the corresponding sides. Corresponding sides very important. In the latter part of the lecture, you will understand why I'm saying this. Up till now, clear? Great. If any doubts, dear students, I am also telling you, you can always comment in the comment box. I will check comments, every comment. I will make sure to answer your query there and then itself. Great. All right. Now, there are some important points. If corresponding angles of two triangles are equal, they are known as equiangular triangles. Now, this is nothing new that you are studying in grade 8. What are equiangular polygons? You remember? Yes, same thing. So if two triangles are there, and if their angles are equal, then they are known as equiangular triangles. And a result of that theorem is the ratio of any two corresponding sides in two equiangular triangle is always the same. That is, if I have a pair of equiangular triangles, the ratio of their corresponding sides will always be equal. Clear? Again, first thing, what do we call as the two pair of triangles who are having equal angles? Equiangular triangles. And the ratio of the two corresponding sides in any two equiangular triangle is always the same. And what we call it as scale factor, denoted by letter K. I hope it is clear. Great. All right. Now, there are many theorems in this chapter, and honestly saying, this chapter is only about theorems. You have to learn this theorem. And again, I'm telling you, derivation, if you want to learn derivation in very detail, like in a very meticulous manner, how it is coming, you will not find it anywhere. You can join our LTC program, which is starting very, very soon. You can just pay rupees 999. You will have the access for entire year. There are going to be live classes. There are no recorded session. All classes are live. Okay, what does theorem 1 says? If a line is drawn parallel to one side of a triangle. So let's say this, we have a triangle. Let me name it as A, B, and C. Okay, if a line is drawn parallel to one side. So let's suppose if I draw a line parallel to AC or BC. Right, let me name these points as M and N. to intersect the other two sides in distinct points. What are distinct points? M and N. Then the other two sides are divided in the same ratio. That is, we will have AM over MB is equals to AN over NC. This is very important, and the proof is also very important. It has been asked in the past, and it will be asked in your midterm exam, midterm exam, pre-boards, boards. It can be asked. Again, I'm saying so. AM over MB is equals to AN over NC. All right, clear. There's converse of this theorem as well. What does it say? Suppose if we have a triangle, let's take same triangle ABC, and it is given a line divides any two sides of a triangle in the same ratio. That is, if I draw it like this, ratio B, well, let's say 1:2, then this line is parallel to the third side. This is just the converse of theorem 1. So again, I'm telling you what are theorem 1. Theorem 1 is, suppose if we consider a triangle, and if I draw a line parallel to any side, then the other two sides are divided in the same ratio. Correct? Okay, what does theorem 2 says? Theorem 2 is nothing but converse of theorem. That is, if I have a line and it is dividing any two sides of a triangle in the same ratio, then it has to be parallel to the third side. Clear? Make sure you pause this video. All theorems are 5-star points here in this chapter. All of them are 5-star. You have to remember this. That is why this is the most important chapter, perhaps in the entire grade 10. All right. Okay, great. So I'll do one example and you will understand how I'm going to apply this. What is given? If a line intersects sides AB and AC, okay, if you have a triangle ABC, a line intersects. So this is line of a triangle ABC at D and D. So these are D and E points and is parallel to BC. That means D is given parallel to EC. We have to prove that AD over AB, not BD, AD over AB is equals to AE over EC, not EC, AC. What does it saying? AD over AB is equals to AE over AC, not EC. That is why it is very important. So what do I know? Again, what is the theorem we studied? Just now we studied the theorem. What can I say? If D is parallel to BC, that can I say AD over DB is equals to AE over AC. Yes. Clear? With nothing, I'm just doing nothing. This is just the theorem that we studied. Right. Okay. I will do one thing. What I'm going to do, just observe. Okay. What I'm going to do, I'm just going to write it in a reciprocal manner. So I can write dB over, okay, I'll do it on the next page. I will write dB. I'm just taking reciprocal, right? dB over AD is equals to EC over AE, right? Now, what I'm going to do, I'm just going to add in both the equation +1 and +1, right? It doesn't change the equality, right? But what I will be getting, I'll be getting AD plus DB over AD is equals to EC plus AE over AE. Now, this here comes the best part. See, AD plus DB. AD plus DB is what? AB. So I can write this as AB over AD. Yes. And this is equals to EC plus AE. EC plus AE. What is it? This is nothing but AC. AC over AE. What I'm going to do next, I'm just going to take once more reciprocal of this. What I'm going to get, AD over AB is equals to AE over AC. And what was required from this? We have to prove AD by AB equals to AE by AC, hence proved, right? Now this, you understand the application of this theorem. That is why it is one of the most important theorem. Great. All right, amazing. Let's do one more question. And this perhaps is the most easiest question. You can do it by using anything. Just pause this video and try yourself. All right, let's resume. What is given? Given that PS over SQ is equals to PT over TR and PST is equals to angle PRQ, we have to prove that PQR is an isosceles triangle. This is very easy. See, first thing, PS over SQ equals to PT over TR. By theorem 2, what can I say? Can I say ST is parallel to QR? Of course, yes. So I have ST is parallel to QR by theorem number 2. Right. Now we have, it is given angle PST is equals to angle PRQ. So if I let this angle as X, that means this angle is also X. We have to prove that angle PQR is an isosceles triangle. Very easy. Since these two lines are parallel, can I say this is also angle X? Yes. Why not? Because they are what? Corresponding angles. So if they are corresponding angles, angle PQR is equals to angle PRQ. What does it mean? That it is an isosceles triangle. See, very easy. Right? Once you understand the theorems, the entire questions are nothing but a piece of cake. Clear? Alright, great. Okay, now what is the criteria for similarity of triangles? Same thing as we considered in the previous section. We have considered criteria of similarity for polygons. What is a three-sided polygon? It is nothing but triangle. So if we have triangle ABC and it is given that it is similar to triangle DEF, and just what we have to take care of is the you remember in grade 9 congruency, what we used to do, we have to take care of the number sequence of the sequence. So ABC is similar to, this is the symbol for similarity. Triangle ABC is similar to triangle DEF if and only if angle A is equals to angle D, angle B equals to angle E, angle C equals to angle F, and the second condition is AB over DE, AB over DE, BC over EF, BC over EF, and AC over DF, or FCA over FT, anything. So in that case, we can say triangle ABC is similar to triangle DEF. What I'm saying, angle A is equals to angle D, angle B equals to angle E, angle C equals to angle F, and AB over DE equals to AC over DF equals to BC over EF. I think it is clear. Right, all right. Now, let's move to another theorem. Now, this is the condition of similarity, but we have some theorems which will help us to prove that two triangles are similar. Now, read this thing. If in two triangles, corresponding angles are equal, what does it say? If we have two triangles, right, and it is given their corresponding angles are equal, that is, this angle is equal to this angle is equals to this angle, and the third angle, let's say this angle, is equals to this angle. Then their corresponding sides are in the same ratio. See, if you see this condition, what is there? It is saying that all the three angles are equal. The second, what is theorem saying? If we have the three angles equal, we can easily assume that their corresponding sides are in the same ratio, and hence the two triangles are similar. That is, we have in two triangles, if three angles are equal, we can safely assume that they both are similar, right? Again, the proof of it is very important, but as I told you earlier, we will be discussing in very huge detail in LTC. The entire genesis of it will be discussed there. Great. All right. Now, this is called as AA similarity criterion, or you can also call it as triple A similarity. Why AA? Okay. See, this is just a conclusion. Suppose in this two triangle, okay, let me draw this two triangle. This angle is, let's say, 70 degree. Let's say this angle is also 70 degree. What, and in this triangle also this is 70 degree and this is 70 degree. Then can't I say that this angle is automatically will be equal to this angle? Right. What is this angle? 40 degree, and in this case also 40 degree. That means we can also reduce this theorem one more bit, that in two triangles, only two angles of triangle are respectively equal to the other two angles of the triangle, then two triangles are similar. So how many angles do we actually need to prove like two triangles are similar? Only two angles. Clear? So you call it AA similarity or you call it AAA similarity. That is, if in two triangles corresponding angles are equal, that is, all corresponding angles are equal, we call it as the triangles are similar. Clear? Great. Awesome. Okay, next let's move to the another theorem that is known as SSS theorem, or we can say as side similarity criterion. What does it say? If in two triangles, side of one triangle are proportional to the sides of another triangle. What does it say? Suppose if I have triangle, let's say ABC, and let me take another triangle PQR. Okay, what is it saying? If the sides of one triangle are proportional to the sides of other triangle, that is AB over PQ is equals to BC over QR is equals to AC over PR. So if we have this condition given, that is, if you remember in previously only we studied, if the three angles are equal, the sides are proportional, and if three sides are proportional, That means angle will be equal. A is equals to P, B is equals to Q, and C equals to R. And again, we can say that triangle ABC is similar to triangle PQR. This is called as side similarity. Clear? So up till now, what we studied triple A or double A and triple S. I hope it is clear. Great. Next, we have another theorem that is known as side angle side similarity criterion. What does it say? If one angle of a triangle is equal to the another angle. Okay, let me draw two triangles here. So if we have, let's say, two triangles, let's say this is A, B, C, let's say P, Q, and R. Now, what is given? If one angle of triangle is equal to another angle, let us assume angle B equals to angle Q. And the sides including these angles, what is meant by sides including? The answer is AB and BC. In this case, it is PQ and QR. They are proportional. That is what it's trying to say. AB over PQ is equals to BC over QR. And it is also given that angle B equals to angle Q. So if we have this condition, that is sides are proportional, second, the angles included between these sides are equal, then we can say the two triangles are similar by SAS criterion of similarity. Great. Again, I'll just repeat you through this one more time. Triple A or double A, all three angles are equal, triangles are similar. Triple S, if all three sides are proportional, the triangles are similar. And SAS, if the angle is equal and the included sides are proportional, the triangles are similar. This is known as SAS similarity criterion. Very easy. Yes. All right. Look at this question now. Now, this is a different question. This is a tricky question. Why don't you try for yourself? Pause the video, give it a try, and come back. All right. Did you give it a try? Okay. Now, in this question, see, it is different. But what we can say, this is 3 root 3, this is 6 root 3, this is 3.8, 7.6, and 6 and 12. So, some ratios we are getting. Okay. Let's start with the simplest one. What I can say, BC over EF is equals to 6 by 12. That is 1 by 2. I can also say AC over DE is equals to 3 root 3 over 6 root 3. Root 3 will get cancelled. 3 and 6, I will get 1 by 2. And with one more ratio, that is AB over DF is equals to 3.8 over 7.6. In this case, also I can write this as 1 by 2. So what do we have? I will write it here. BC over EF is equals to AC over DE is equals to AB over DF. Now, the thing is, we have got the three ratios of our corresponding sides as equal. That is, triangles are similar very easily by SSS similarity. But which two triangles? Now, see, in this case, you have to apply a bit mind. See, ABC is there, right? And corresponding to AB, which side is equal? DF. Corresponding to AC, it is DE. And corresponding to BC, it is EF. So if I go it like this, ADFE, will I get my answer? Of course, yes. So what I can write, triangle ABC is similar to triangle DF and E. Okay, now you can also cross check BC over EF, BC, EF, AC over DE, AC over DE, AB over DF, AB over DF. Now, which angle we have to find? I find angle E. So I can clearly say that corresponding to angle C, angle E will also be equal, right? Now, in this question, what is angle E? 80 degrees, 60 degrees. I hope you remember angle sum property of triangle. This will be 40 degrees. So if angle C is 40 degree, we can safely conclude that angle E is also 40 degree. You understood how we are using the properties, the theorems that we have learned in questions. All right, awesome. Now let's do one more question. Now it is given that OA into OB, that is, this is OA into OB is equals to OC times OD. This is OC times OD. Show that angle A is equals to C and angle B equals to angle D. Very easy, right? Now first thing first, tell me if this angle is X, what is this angle? X. Why a vertically opposite angle? Now what is given? OA into OB equals to OC into OD. What I will do? I will take OA into OB is given. So I will take OC here. So I will get OA by OC, and I will take OB to that side. I will get OD over OB. right? Now, see, OA and OC are proportional. Similarly, OD and OB are proportional. So, what kind of similarity is it? The two included sides are equal and their included angle is as well as equal. So, this is SAS similarity. I can easily write triangle AOD is similar to triangle COB. So, then this by CPCT we can write angle A equals to angle C and angle D equals to angle B. Not exactly CPCT, don't get confused there. But I hope you are getting it right. Okay, corresponding parts of similar triangles, we can say. Okay, so that is great. Let's do one more question. Very easy question. But this type of question you can get in both chapters, that is trigonometry, when you're learning heights and distance, and of course in similar triangles as well. What is it saying? A girl of 90 centimeter height, that means height of girl is 90 centimeter, is walking away from the base of lamp. So this is lamp at a speed 1.2 meter per second if the lamp is 3.6 meter above the ground. So I can say that length of this post is how much? 3.6 meter, or I can write 360 centimeter, right? So height of girl is 90 centimeter, height of lamp post is 360 centimeter. Now find the length of her shadow after 4 seconds. That means after 4 seconds she has reached this point, right? Now speed is given 1.2 meter per second. I hope you remember the formula. Speed equals to distance over time. Now speed is 1.2. I can write d equals to speed is 1.2, and in 4 seconds how much she have covered? So into 4. So I can easily write 1.2 times 4, 4.8. That means distance of BD is 4.8 meter, or if I remove this, 480 centimeter. So in 4 seconds she have worked 480 centimeter. We have to find the length of her shadow. That is, we have to find the length of DE. Again, very simple. I'll just draw the triangle one more time here for your convenience. So we have this right angle triangle given to us. Okay, what is the this is 360. What is the height of the girl? 90. And how much she have walked? She have walked 480. Okay, we have to find this value of x. Now see, let's consider A, B. Let me name this D. This is C, this is D, and this is E. Now consider triangle ABC and consider triangle DEF. Okay, what can I say? Can I say AB over DE is how much? 360 by 90. That is 4, right? Can I also say angle B equals to angle E? Angle B is equals to angle E is equals to 90 degree. And of course, angle C is common. So angle C is common. So if you have two angles equal, what can I say by an AA similarity? Triangle ACB is similar to triangle DCE. Or in this case, I can write, that is, we want BC, right? So BC over CE is equals to AB over DE. Correct. Now, what is the length of BC? 480 plus x. What is the length of CE? X is equals to AB, that is 360 over 90. Now, this is nothing but 4. 90 times 4 is 360. So from this, I will be getting 480 plus x equals to 4x. If I take x this side, what I will be getting? 480 is equals to 3x, or x equals to 480 by 3. That is 160. So length of shadow is 160 centimeters, or we can say 1.6 meters. I hope it is clear. Yes. All right. So there's one bonus, and this is not in the part of your syllabus, but let's read the statement. What is it saying? If a two triangles hypotenuse and one side of one triangle are proportional to the hypotenuse. If you look at the previous question, we had dealt with right angle triangles, right? So read this statement one by one. If in two right triangles, hypotenuse and one side of one triangle are proportional to the hypotenuse at one side of the other triangle, and the two triangles are similar. This is nothing. You don't have to worry about that. So if we have, let's say, two right angle triangles, I'll just explain it still. Okay, hypotenuse and one side, that is, if this is x, let's say this is y, this is a, and this is b. So what it's trying to say, that x by y is equals to a by b, then the two triangles are similar. This is not in syllabus, but always good to have great knowledge. All right, I hope you understood this. Right. So there's one question for you. If angle B and angle Q are acute angles such that sine B equals to sine Q, then prove that angle B equals to angle Q. Now, of course, this figure is not the correct figure. So I hope you are able to understand this. Do solve this question and let me know in the comment box below. And of course, once again, download the Sysya Class app. And again, we have this offer going on, which is in just 999, you are able to get 1 year program for grades 3 to 10. Do enroll in our course, and thank you so much for joining. I will see you in the next video. I will bring some another chapter, and stay safe, like study hard. It is very important. All right. Okay.